Hello and welcome back to Coding with Unity. Today, we'll be doing the 3D item model equipping onto your character so that your item models will move with your character animations. We'll also be talking about different ways of doing it and the pitfalls and advantages of doing certain things. And we'll be discussing different programs you can use if you're not a 3D modeler and you just need to get some items into your game without actually knowing how to model or rig. We're going to use Fuse and Mixamo to automatically generate the models and rigs we need to combine these characters. That's where I got all the models that this character is currently using, and I'll show you how I did that. But so you know, it is better if you're a 3D modeler, which I'm sure if you are a 3D modeler, you already know this. It's better to make your own models and your own rigs and your own items. Then you can customize them and have them be more performant and things like that. But for prototyping or programmers or anyone who's not good at art, this would be a great way for getting assets into your game to quickly get up and running while waiting on the actual assets that your game will be using. So to get started, let's open up the project that we are using in the last video. And you see I have this project opened up now. So if we go and look at this character right here, if you open up his hierarchy, you'll see he has an Ethan skeleton. And if you hold down Alt and click the drop down arrow, it'll show everything. And if you click it again with Alt held down, it'll close everything. So it'll be closed the next time. But anyways, this shows all the bones for your character. And what we're pretty much going to do is we're going to create items that use the same bone names as the area where we want to put the item. So if we wanted new boots, we'd probably need left toe 2, left toe 1, left foot, probably left leg because we need the bend for the lower part of the leg, and we'll need the same thing on the right leg. You can also use every single bone, but it's a little less performant. And I'll talk more about that when we actually get the code in and we have the models and the items that we're going to be using. We'll rip the bones off of one item and I'll show you the difference, why it's maybe not better to do that for every item and it's better to import your items as sets, possibly, or just have one armature that every item references from. But we'll get more into that when we get to that part of the video. So all you really need to understand now is your model has a skeleton. Each part of your skeleton has different names for that part of your model, and it controls how that part of the model moves. So if I was to click on left leg, click on rotate, and bend it, it's going to bend the left leg. How that works is with the weight painting of the model. The weight painting determines which part of the mesh the bones are going to affect, and that's all done inside the 3D modeling program, which we aren't going to have to worry about in this video because Mixamo will handle the rigging for us, and Fuse is going to handle the model generation and item generation for us. But all we need to do is create an item that also has weight painting and bones that says when the leg moves backwards, this item should move backwards also. And then we're just going to take the bones off of the item that we made and put it onto our actual character and tell our new item to use the bones of our character instead of the bones that are on the item that we created. So it won't add any more bones to your hierarchy, it'll just be using the bones that are already there and adding the object and its weight painting. I hope I explained that well. Maybe I over-explained it, maybe it was confusing, I'm not sure. If you have any questions, leave a comment below, or easier, join my Discord. I'll definitely answer you easier there. But if you are going to do that, consider leaving a comment on the video also for the YouTube algorithm so it'll help the video get a little more traction. And while you're doing that, go ahead and like the video and subscribe to the channel also. These videos take a long time to make, especially since I'm doing a series and not one-off videos. It's pretty dang difficult, so the least you could do is click the subscribe button. But anyways, let's move on to getting Fuse. So I have an Adobe Creative Cloud account, but last I checked, Fuse is free. So you shouldn't need an Adobe Creative Cloud to be able to use it. So we'll just go to we'll just go to Google and search Fuse Adobe. And here it is. Yeah, it's still in beta, and I'm pretty sure it said while it's in beta, it's going to be free for everybody. But I could be wrong. If I am wrong, yeah, it's giving me the download button without being signed in, so it should be fine. Yeah, for a limited time, Fuse is available as a free beta to Creative Cloud members. Oh, so maybe you have to be some form of member and Fuse comes free with it. I'm not sure. Y'all just have to let me know on that. If you're not able to use Fuse, guess you're going to have to model your own items. I'm not sure. But we're using Fuse for this video. So once you already have Fuse downloaded, go ahead and open it up. And when you open it, it's going to look something like this. Your layout may be different because I'm on a 144% DPI for my monitor, so it's easier to see the smaller objects on my screen. So all we need to do is assemble a character inside of Fuse. So go ahead and do that. I'm just going to use all the basic male character pieces. So once we have our model created, we can send it to Mixamo to get the nude version of our model. So let's just go ahead and click the Send to Mixamo button. I'll call mine YT Character Model Nude. I'll click Save, and it's going to export the model and send it to Mixamo. Once it sends it to Mixamo, the auto rigger is going to run, which may take 1 or 2 minutes. It doesn't take long at all. So just wait for the auto rigging to finish. If you're not using Fuse to create your models and you already have a model that's in T-pose, you can send that model to Mixamo and have Mixamo rig your custom model. As long as the character is created to look pretty much like a normal bipedal human, Mixamo does a pretty good job at rigging the model. But if you have a model with a really large head, it may not rig it perfectly, and you might be better off just using Blender's built-in rigger because it works pretty much the same as the auto rigger inside of Mixamo. But we're using Mixamo because we're using Fuse models, so it seamlessly works together pretty well. Once Mixamo finishes rigging your model, it'll load up and you can check and make sure that everything is rigged nicely. Everything looks pretty good to me. Looks like it's moving pretty smoothly. I have no complaints. You can also lower your skeleton LOD, which is probably a good idea since we're doing item equipping. There's no reason to have such an extensive skeleton. So for your project, you might want to disable the facial blend shapes and use a 2-chain finger or maybe no fingers. But I'm just going to leave mine as default. So we're going to go ahead and just use facial blend shapes and standard skeleton 65, mainly because I want to push the performance of the system that I'm creating. So if it runs good with 65 bones, then it should run great with a 2-chain finger, because pretty much half your model's bones are almost in your hands alone, so just something to keep in mind. So I'll go ahead and click Finish, and we'll use this character. Now we can download it, but I already have one downloaded, so I'm not going to bother, but go ahead and download yours. And then how we're going to get the items is we can go back into Fuse and go to Clothing, and you have a whole bunch of items that Fuse already has added into it that we can add to our character. I'm going to show you how to create a set of items, and then we'll also use a set of items that I imported and created, this is the one that I imported and created. It's the Knight Armor. It's the one you saw at the beginning of the video, which is also a Mixamo item. I sent the Knight model from Mixamo to my friend, and he cut the Knight pieces into parts, and then I re-imported those pieces into Fuse so that I can put them onto a customizable character. But that's a lot more work than what I'm going to show you in this video. It would have taken me forever to do that, and he did it pretty well. You can see at the beginning of the video it has a few little problems, like you can see right here the leg is sticking through a bit. But in a final system, you'd want to split your character into parts also and disable parts of your character that there's a model on so you don't have to worry about the overlapping meshes. And it's more performant. No reason to have to render the tries underneath the model that's covering it up. So let's just use some built-in Fuse items for now. I'm going to use the cop outfit. I think it's called like Combat, I believe. And after I have this set up, I'll come back. It's called Tactical. Once you have your character set up, we're going to send it to Mixamo. I'll call this one Tactical Set. Now that our Tactical Set is also rigged, we're just going to go ahead and click Finish. Just keep in mind, if you did your facial blend shape changes and skeleton LOD changes, make sure it's the exact same on the items that we're doing now as the base character model that we did before. The items need the same bones as the character model for this to work correctly. So we're going to use this character and we're going to download it as an FBX for Unity in T-pose. Then let's go into Blender and we're going to import that object that we just downloaded. So we'll import it. If you don't have Blender, it's a 3D modeling program. I don't think I need to explain that, but just go to blender.com and download it, or use whatever 3D modeling program that you prefer. But we need to delete an object off of this model. Technically, I guess you don't have to do that. You can leave it on and just import the model into Unity also, but that's making the file way larger than it needs to be. Not that I'm making it as optimized as it could be, and I do suggest if you're watching this video and don't know much about modeling, go look more into modeling, because there's a lot of stuff you could actually do to make this file size smaller to help your game out. But that's just well beyond the scope of this video, and I don't even know all those things, so I'm not a modeler. But let's import the object that we just downloaded, wherever it is, somewhere. It's in my downloads folder. I know that much. My downloads folder is... Alright, once it imports, let's open up our armature, and we're going to delete the body. All we need is the items. So we can collect the body, the default, and the eyes. Right click and delete those, so you can see all we have is the items now. There's no body inside. So we're done with what we need to do inside of Blender. We can just export this out into a new file, or you can overwrite this file. Either one's fine. I'm just going to go ahead and export it straight into the project that we're working on, because we're going to need it anyways. I'm going to call it Tactical Set, and I put it inside of a new folder called Models inside of the Graphics folder. We're going to export the FBX straight into Unity, so if we open up Unity, you'll see it automatically generated the Models folder, and there's nothing in it. Strange. I might have had selected only turned on my export. So let's go to Export FBX. It says it's in it. It's not here though. Okay, it just took a minute to import it. Then it's going to import into Unity. If you drag and drop it into Unity, it is massively ginormous and laying on his back. So let's go fix that inside of Blender. Alright, so we'll go back into Blender, and we're going to click on our armature, and we're going to change our size to our scale to 0.001, 0.001, 0.001, and now we need to apply our scale, but we can't just apply it to our armature, because if you do, it's going to change the location of our models, which is not what we want. So I'm going to hit Control Z to get it back to being unapplied, so our scale is still 0.001 on our X, Y, and Z. And what we're going to do is select the models and not the armature. And then we're going to hit Control A and apply all transforms. Or all rotation and scale. Now all our rotation and scales are zeroed out and our scale is 1. So we're going to go back into our file, export, FBX. And you noticed we were laying on our back also. Usually just click this experimental apply transform and it'll fix that if that ever happens. Let's go back into Unity and see what happens. Nothing changed. Cool. Let's go to our armature, click Control A, and we're just going to apply the rotation and nothing else. Now let's File, Export, FBX. Once it's imported, let's drag it in. You can see it's no longer lying on his back, but he's still way too big. One thing you can do is just change your scale factor to 0.01 and click Apply. We can just change the scale factor to 0.01 to get the scaling right inside of Unity. Normally you'd fix this inside of Blender, but I just spent like 30 or 40 minutes trying to fix it, and the things that I normally do just weren't working, and I'm chopping it up to it's because I have like 7 programs open and I'm recording with OBS at the same time. I'm just going to assume it's some type of bug, because I can't get it to scale down from inside of Blender. I'm probably just going to cut that footage. It's not really worth watching. Let's just change our scale to 0.01. Hopefully it'll still work. I've never tested it by just scaling it inside of Unity, but I'm not going to spend more time on it. So we have our tactical set inside. We need to bring the nude character that we downloaded into Unity also. So locate the nude character that we downloaded earlier in the video and bring him into your project into the same models folder. And if you don't have views or a way to get models, just download the project in the description below and you'll have all the models that are in my project to get you up and running. I'm just going to delete this because I already have a tactical set that I downloaded before that is working without the scale being messed up. You can see my scale factor's on 1, so I wasn't just talking shit earlier. I actually was able to do it. For some reason I couldn't now. I'm deleting it using the old one. So now that we went through the programmer hell of dealing with 3D models and we have our 3D models into our program, But you can see we don't have the textures. If you want the textures, you can go back into Fuse and go to File, Export, Export Textures, and it'll export all the textures of the items that you're using. I'm just going to drag in the textures that I already exported of my armor set from my other project. And we have a bottom mat, glove mat, and hat map. So I can go back to my armor set Unity, go to Materials, and we can just set it right here. We'll go into Night Materials, Bottom Mat 01, Glove Map, Hat Map, Shoe Map, and Top Map. Click Apply. Now we have a textured armor set. Beautiful. Now we have our models in. We have a armor set that is a tactical uniform, like an FPS shooter. And we have an armor set like you would want in a medieval game. And the next thing you're going to want to do is import your character that you downloaded earlier. And the materials for that character. The way you'll get the materials is the same thing that I showed before. Go into Fuse. You can take off the items or leave the items on. I think you'll still get the nude body textures when you export. But if you want to make it easier, just click on an item and click delete on your keyboard and it'll remove the items. And then you can go to File, Export, Export Textures. Select a location where you want to export them. Use the physical based or Unity 5. Either one I believe will work fine. Maybe Unity 5 will make more sense inside the editor, but I think I used PBR based. Can't really remember. So now that you have your character model imported and the materials for that model, let's drag our character model into the scene. Here's our nude character. Let's apply his materials the same way as we did with the armor set. We'll click on him, go to his materials inside the inspector. His exposed materials that came with the model are exposed, and we can just drag them in. Click apply, and there we go. If you're following along with this and you're using Fuse models and your eyebrows are messed up, go to the material that your eyebrow is using, which I believe is, you can tell by just clicking on default in eyes. It's using 3 for the eyeballs and 4 for the eyelashes. So we'll go to 4 and we can change the rendering mode to fade. So it'll go from this ugly black to the fade that we need for the eyebrows. You can leave the others on opaque. Also adjust your sliders to get a better reflection that you want on your character. But now that we have our character imported and everything set up how we want it, let's put our character controller scripts on it. So we'll be replacing Ethan with Joe. I think we'll just add these files to our armor set body nude and rename this to player. So we'll just copy and paste everything that we need. So copy component, go to the player, paste component values. I think it's fine that it uses the Ethan avatar. I believe their bone structure is pretty much exactly the same. We'll paste this as a new component. You can see when you paste the third-person character controller in, it automatically adds the other script in also. That's a good thing. We need both of them. But copy the values from this script so it has the same values. So we'll paste component values. Then we can copy our player script that we had created from the last video also and paste it onto here. You'll see all the attributes and stuff are the same from the other character. That'll make things a lot easier on us. Our tag is untagged in the layer's default. We don't have to worry about that. So we can go ahead and delete this character. If you need it for reference for any reason, just disable it. Then we'll go to here. And the collider is good enough. Let's just click play and see if we're able to move around with the... Oh, one last thing we need to do is if you're using Cinemachine, we need to reconnect our target. Apparently our Cinemachine is completely broken. That's strange. Let me fix my Cinemachine. I re-imported the project and it re-added our scripts to the main camera. So we can go to CMCam and awesome, it re-added this. I'm not sure if the values are the same. We can fix it though. But we still need to replace what I was going to say. Since it did update it back with the third-person controller, I'm going to assume it updated everything. We're going to replace this with the player we just created. So now we're focusing on the player. And let's also make a prefab out of our player. So just drag and drop it in here and make it an original prefab. We don't want to make it a prefab variant of its like base 3D model. We want an original prefab. So we have our player as a model or a prefab. Let's click play and make sure everything is working. Everything's working beautifully, except he's not animated at all. The reason is if you go into your models and click on armor set body nude, go to animations, or go to rig. We need to change it to a humanoid and click apply. Let's click play again, and he's still not animating. Let's use the armor set body nude avatar, see if that fixes it. There we go, now it's working. You can see we can do everything, we can jump, everything, all the animations work exactly the same for our Mixamo character as the animation that came with our Ethan model. Can we pick up items still? Excellent, everything seems to be working exactly as expected. Let's just make sure we can equip stuff. If the camera looks stuttery, it's just because I have so many things open. So now that we have our player working and our armors imported, we need to start setting up the code for attaching the armor to our player. So the first thing we're going to want to do is go into our item object script, and we'll add a variable slot to put our character display item. So we have a UI display here, so we'll put it right next to this. We'll call it public game object character display. Then when we go back into Unity and look at our items, you'll see it has a variable slot to put a character display. The way we'll set that up is by going to the models that we created, open it up, and this is a bones. Let's go to an item that makes sense. We'll use boots. Go back to your models, and we'll drag in some armor set Unity shoes. Now we need a way to pull this model from our item object and put it onto our character. So that's going to be done currently inside of our player script where we apply our stats. In the next video, we're going to do a bit of refactoring and we're going to split our player script into a player stats and a player equipment script, which is better because we won't have our player script clogged with a whole bunch of stuff, and it'll just be a localized script for controlling all the things that the player does and not exactly how the player does it. But for now, we're going to use our equipment place where our stats are applied and removed from, and we'll add our armor here and remove our armor here. And to make this a little easier to look at, we're going to change on before slot updated to say on remove item, because we know when this fires we're removing an item, and when this fires we're adding an item, so we'll say on add item. That'll make it a little easier to read later down the line when we don't exactly remember what these functions do. Just one thing to also say, you could, instead of saying string.concact, I learned that using the money sign is just as performant, and then we can just put these right here. So that's pretty much saying the exact same thing, but I believe it looks a little cleaner to me, and it's a little easier to write. It's really your preference, though. Just place a money sign, and then you can put these around all your variable calls. But anyways, inside of here, we're going to add the item to our character. How we're going to do that is we need to check, does the item that we're equipping have a character display? So we'll say _slot.itemObject.characterDisplay is not equal to null. That means there's a character display that needs to be added to the item and not just stats that need to be added to the item. Now we need to figure out what type of item that we're adding to our character, and how we're going to say that is by saying switch, then you can hit tab, and we'll type slot.allowedItems 0. So what this is saying is we're getting the inventory slot that we just dropped an item onto, and then we're looking at the allowed items of that inventory slot. So if we go back into Unity and we go to our equipment and we look at it, all of our slots have an allowed items. We have a helmet, a weapon, a shield weapon, chest, and boots. So you're probably thinking, well, 2 of these have a weapon, so how do I know which one's a weapon and which one's a shield? In this iteration of the system, just make sure shield is in element 0, and we know that that's the offhand. And how we're going to code it, you'll be able to place a weapon or a shield in there. It'll work perfectly. Maybe not the best idea. Maybe we'll come up with some type of offhand thing instead. But because of how we're coding it, we want main hand weapons to also work as offhands, so we can't just tag up offhand type items unless we add in a double tag system, which I don't feel like doing. This is much easier than that. So just make shield in your element 0 if you want dual weapons, that is. So now we know using slot.allowedItem0 what slot we just placed an item in. So let's make a case for each item type. And since I'm using JetBrains, there's actually an easy way to do that. I can just hit Alt-Enter and generate switch labels. then remove the ones I don't need. We don't need food, and we don't need default, helmet, weapon, shield, boots, and chest. Sounds like all we need. Now we need to make a variable slot to hold the 3D model that gets generated for each one of these items. And maybe you're starting to see why this should be split off into a player equipment class now, because we're cluttering this up with so many different things that it really doesn't make sense. So I'm going to type in all the variable names for the items that we're going to use, and we'll get back to it. So we have a variable to store each item. We can go back into here, and we're going to say things like underscore boots is equal to some type of script that we're going to access to combine our bones. Let's call it bone combiner. You can see I'm adding these underscores now for my variables that are in scope for the whole file. It's makes more sense to me, and I'm starting to switch all my things over to that. I guess I'll stick to my old way of doing it for this video, but yeah, I'm switching to that for now on. So we'll have some type of script called bone combiner that will create on the entity that needs bones combined. And we'll access that script, and we'll have some type of function that says add limb. And on that function, we're going to pass in that character display that we created, which would be accessed with underscore slot dot item object dot character display. So we need to set this up to make it work, meaning we need to create the bone combiner. So let's just line this out for now so it doesn't give us an error. Go back into Unity and let's create the file. So we'll say create C#, we'll call it bone combiner. Go ahead and open it up. And inside of here is where the real meat of this video is at. It's probably what you actually came here to see. And I'll probably tag what part of this video starts at the beginning for people who just want to see the code itself and aren't worried about how this integrates with the rest of my series. It's really not a lot of code to do this either. It's just can be really performance heavy depending on how you do it. The way I ended up doing it, there's no telling if other people do it this way or not, but I got it to end up being as performant as I can reasonably think to get it without just coming up with some crazy other ideas. So let's talk about that. So now that we have our bone combiner script up and we know that we're trying to add a limb using the character display and our bone combiner script, the first thing we need to do is get rid of this boilerplate code. And now let's talk about how this is going to work. I gave a simplified understanding of it in the beginning of the video, but I don't know how well explained that was. It was like 2 hours ago now at this point, maybe 2.5, not sure. But, so we have our player who has an armature, and he has all these bones on it, and we have an armor set, which has all these bones on it. We want to add the bottoms of our armor set to our player. The bottoms, if we could see our bones at the same time, do we have this set open? We have this set open so we can x-ray these bones and I'll be able to explain it. So we're trying to add pants onto our character, and the pants and our character use the same exact bone structure. We have these legs here, so to bend our pants we need these bones and these bones. Maybe these bones and maybe these bones. You can decide that on your own. You might want a little bit of bend on your pants leg when your foot moves. It's really depending on how much performance you can allow towards your item equipping to depend on how nice the item will turn out being once it equips. If you want to just apply the entire armature to every single item that you put on, you can do that. It's just going to be 67 calls every single time. You're going to be needing to reference your character's bone structure and your item's bone structure 67 times. So that's your choice. You can do it for sure. But 67 is a lot more than, 1, 2, 3, 4, 5, 10. So your choice. So we just need the bones of the object that we want to equip, or we can equip every bone. How we're going to start off is by equipping every single bone, and then I'll show you a way to only equip the bones that the item requires. And then I'll show you why importing all your items with just the bones that it requires and importing the entire set with one armature both have their caveats. Importing each item separately ends up being a lot bigger file size wise than just importing the whole set with one armature, mainly because of the bone structure and stuff. So there may be other things you may be able to think about to make the system better, but let's move on for now. we will be removing the bones from this model and using the bones from our character instead. So let's do that in code. Inside our bone combiner script, let's first create a dictionary of our character's bones because we don't want to have to look up our character's bones every single time we equipped an item. Let's just do it when the game starts, and then we won't have to worry about it again. So we'll make a public read-only dictionary, and the dictionary is going to be an int, which is going to be the key for finding the transform, which is the reference to the bone. And we'll call it _root dictionary or root bone dictionary. Now let's make another private read-only array, and it's going to be an array of transforms. And we'll call it bone transform, and we'll give it a new transform with a size of 67. So what this bone transforms array is it's going to be an array that's set to the size of our bone structure, and it's going to hold the bones that are returned from this root bone dictionary. So if we're equipping gloves, we'll get the glove bones from the root bone dictionary using the bone names of the item we're equipping as the key, and return the root bone dictionary's transform and add it to this transform array to give those bones to the item we're equipping. That'll make more sense once we add in the rest of the code. Now let's just add in a private read-only transform. This is just to hold the transform of our root object's transform, or our player. Now let's make a constructor for this class. We'll say public bone combiner. We'll pass in a game object, which the game object that we pass in will be called a root object. And what the root object is the player, essentially. Now that we have our constructor, we'll use this constructor inside our player to create the bone combiner. So now we need to make the add limb function. So let's say public transform add limb, and we're going to pass in a boned object. So we'll say game object boned obj, which what that is the item or limb that we want to attach to our player. So as you can tell maybe from the naming, you could also use this for more than just equipment. You could actually attach new arms or new heads to your character and things like that. So inside of here, let's say var limb equals, and what it's going to equal is a function that we haven't created yet. We'll be creating it next, and it's going to be called process boned object, which basically is going to be creating the boned object that we'll be adding to our player. And we need to pass in a renderer, so we'll say boned obj.get component in children, and we'll be getting the skinned mesh renderer. We don't have this added yet, so let's just line it out so we don't get an error. We'll just say return transform, just to get rid of the error. So now we need to make this process bone object function. This is where the meat of this class takes place. So we'll say private transform process boned object, and the process boned object needs a skinned mesh renderer. We'll call it renderer. Now we can add this in, add a semicolon on the end. This function will return the limb, and let's finish the process boned object. Inside of here, we need to first create our sub-object, so we'll say var boned object equals new game object dot transform. That's going to instantiate a new game object into the scene and then return the transform of that game object to this variable that we created. Now we need to add a renderer to it, so we'll say var mesh renderer, because we need a reference to that renderer that we're about to add, equals boned object dot game object dot add component. The component that we want to add is a skinned mesh renderer. Now let's get the bones on the skinned mesh renderer that we passed in. So we'll say var bones equals renderer.bones. Using those bones, let's do a for loop over the bones.length. And inside of here, that bone array that we created earlier, we're going to populate it by saying underscore bone transform I equals, and this is where we need to use the root bone dictionary, meaning we need to make a way to populate it. How we're going to do that is create a function called traverse hierarchy, and we're going to pass in our transform. Now let's create this function. I'm going to move it to the bottom of the class. And this function's going to be quite a heavy function, but we're only going to use it one time when the game is started for each character that needs item equipping, actually. So you could actually do this in the editor maybe, but we're going to do it when the game starts. So we have a private void traverse hierarchy, and it passes in a transform called transform. And we'll do a for each loop, and we're going to be doing the loop is over the transforms. The variable name will be child, So we're looking for all children in transform. Now we'll say root bone dictionary dot add child dot name. Make the for each a transform child in transform. Then we'll say transform child dot name dot get hashcode. Then we'll pass in the child itself. What get hashcode does is it returns the hashcode representation of the name. This should just make it a little quicker for accessing the dictionary than using a string. So we're adding the child into our dictionary, and we'll use the hash code of the child's name as the key to return the transform. Now, to make sure we add every single child that is on this object, we're going to do something a little heavy. What we're going to do is rerun this function and pass in the child. So we'll just keep rerunning this until we run out of children. Now we can use traverse hierarchy right here to populate our root bone dictionary. And now that our root bone dictionary is populated when the game starts, we can go back down to this for loop that we are creating and say underscore bone transforms I equals underscore root bone dictionary bones I dot get hashcode. That'll use the name from the bones on the object that we're adding to our player. It'll use the name of that bone and use it as the key to find the reference of the bone that is on our player. And we'll return that and store it in this bone transforms array so that we can apply these bones to the mesh renderer that we just created. So now that we've assembled our bone structure, let's assemble the renderer by saying mesh renderer dot bones is equal to underscore bone transforms. Then we'll say mesh renderer dot shared mesh is equal to renderer dot shared mesh. Then we'll say mesh renderer dot materials is equal to renderer dot material with an S on it. Make sure there's an S on both of them in case your items have more than one material. Now let's return our boned object. Return boned object. So we created our sub-object, we added the renderer, we assembled our bone structure, and we assembled our renderer. Then we returned our boned object, which returns it to the limb. And now that we have our limb created, we can say limb.setParent, and the parent's going to be underscore transform. And that's everything. That's all of the code that we need for adding an item to our player. Zoom out on it a little bit so you can see more at once, and then I'll zoom in on it also, just in case for some reason our code hasn't been as easy to read for people. All right, excellent. Let's go see if this is working. We just need to unline this and create our bone combiner inside of player. So we'll say private bone combiner. See how JetBrains recommends putting an underscore? That's one of the main reasons I'm starting to do it. Inside our start function, we'll say bone combiner is equal to new bone combiner transform, game object dot transform. Oh, we just passed in the game object. My bad. And we want to go into our bone combiner, remove the mono behavior. Then we can save that, go back into player, that yellow line goes away. So we have our new bone combiner created. So we can use the bone combiner to combine a limb. So let's just copy this for each area and then fix the slot that it gets referenced to. Our helmet should be a helmet. Weapon should be a weapon. I think I called it sword. Shield should be an offhand. Boots are boots. Chest is chest. Alright, so all the code should be set up now. It should just work. Let's go back into Unity, make this smaller. Let's set up some items. We have the boots set up already, so I guess let's just test these boots and make sure they work. Let's see what these boots look like. It's the leather looking boots. Let's click play and see if it actually works. We got an error. Key not found exception in the bone combiner. Right here where we're getting the bone name, we forgot to say .name. We need to get the hash code of our name instead of the hash code of our transform array entry. So now that we made that change, it should work. So we picks up some boots, put them on, and it works, but we got some type of material error. That's strange. Not allowed to access renderer.material on prefab object. Use renderer.sharedMaterial instead. Isn't that what I'm doing? Oh, I forgot to type shared materials. Change this to say shared materials, then we're going to save, go back into Unity, click play, and see if we get another error. And there we go. It's working without an error. It's moving with our animation. You can tell the toes are moving a little bit. If we do this, we can hit Shift F to focus on our player. Then let's just get a better view. You can tell it's bending with our kneecap. It's doing exactly what we expect it to. Cool, so let's just set up some other items so we can have a full set that our slots allow us to. I'm not going to set up the other slots because if you watch the previous videos or if you have your own inventory system, you should know how to do that, so that's just going to make the video an extra 30 to 45 minutes longer for me. And for my own sanity, I'm not doing it. So let's set up we can set up a helmet, a chest, and boots. So our helm one will be a hat. Our chest one will be the tops. So we have boots, chest, and helmet set up. We got to add in different code for the sword and shield. We're not going to use a bone combiner for that because that's overkill. So we have a chest, helmet, and pants set up. Let's make sure those work. I don't exactly remember which the items look like for that, so we'll just pick up a bunch of stuff and test them. Is it this one? Nope. Is it this one? Yep. Cool. And we do know what the boots are. So excellent, it's working perfectly. We can focus in on our player with Shift F. You can see everything's moving with our animation. There are these little gaps though, and to fix that, you can split your character into pieces and either just disable it and enable it, or you could actually delete it completely and re-add it with the same exact code that we're adding items with. But it's probably more performant to just disable and re-enable it. So yeah, that's how you combine items. I'm sure that's what most of you came here to see, which we're pretty much done, but it's actually extremely performance heavy to access the name in a for loop as many times as we are. So let's look at the performance impact of how we're doing it right now. So we'll go to Windows, Analysis, Profiler, and you can see I have my profiler open, but I have it on my secondary window. So let's pick up some boots, and I'm going to bring this right here so you can see it actually. We'll just dock it to right here. Now that it's stabilizing a bit, let's go ahead and put the boots on and see what type of spike we get. Pause it, click on our spike, let's de-dock it, go to the hierarchy view, and we can just type in the name that we're looking for. You just have to stop recording to do that. We're looking for the add limb function. So here's bonecombiner.addLimb. It allocated 8 kilobytes of garbage and took 1.48 milliseconds. That's not bad. If you want to leave it like that, that's fine, but I'm going to show you a quick way to make it faster. If we go inside of this and take a deeper look at it, the bone combiner runs process bone, which gets the item. It runs 67 times. If we look at object.getName, 4.6 kilobytes of our garbage collection comes from that. So we can get rid of all of these object.getName calls by doing them inside the editor and just storing on our item object instead of referencing all of the names when we add the item. It's pretty easy to do. Let's do it real quick. Turn off deep profile. Leave play mode. So we need to store the bone names of our character display bones on the item object. To do that, let's open up the item object, and right here is the item object. So inside of here, let's say private void onValidate, which onValidate runs inside and outside of play mode every time a variable changes. So inside of here, we're just gonna, every time a variable changes, look and see if we have a character display on this item object. If we do, we're going to see, does that character display have bones, aka a skin mesh renderer? And if it does, we're going to store those into a list. So we'll first want to clear that list because we don't want to keep restacking it. But before that, let's actually create the list. So we'll say public item or public list, and the list is going to be filled with strings. we'll call it bone names, equals a new list of strings. And every time on validate runs, let's do bone names.clear. You could also do, is there bone names already? If so, just return out of this, but then it wouldn't update when you change the item, so that's your choice. This isn't like, how I'm doing this is in no way a blueprint way of doing it. It's how I'm doing it, and you should pretty much take it for a grain of salt, do more research, and figure out if it's the way you want to do it or not. But it does work, and I'm showing you the profiler results of it being reasonably performant. Once we do this, it's pretty fast, and it's hardly any garbage collection, so it should be perfectly fine for a production game, to be honest. I'm sure there's plenty of production games that have done it worse, in my opinion. So if there's not a character display, we'll return. We don't want to run any more code. And now we'll check if the character display doesn't have a skinned mesh renderer, then we'll also return and not run any more code. So if it does have a character display and the character display has a skinned mesh renderer, let's get the renderer by saying var renderer equals character display dot get component skinned mesh renderer. Then let's get the bones off that skinned mesh renderer by saying var bones is equal to renderer dot bones. Now we'll do a for each loop over those bones. So we're doing a for each loop over all of the bones and getting the transform for each one. So we'll just say bone names dot add t dot name. So we have a list of bone names inside of our item object that'll get stored every time we add or change or remove a character display, and any other variable also. So now that we have this list of bone names inside of our player, we can just send that list of bone names along with the item that we want to equip. So we could just say underscore slot dot item object dot bone names, and we can put this on each one. Now we'll go into our addlim function, and our addlim function needs a list of strings called bone names. So let's make the list of strings and call it bone name. And what we're going to do with that inside of this function is just pass it off to the processed boned object. So we'll pass off the bone names to the processed boned object, going down to here and adding the list to here too. So we'll say list of strings, call it bone name. Now using this list of strings bone names, we can actually get rid of this call to renderer.bones, which is a pretty heavy call in our profiler, garbage collection wise. So that's a positive. And we can use bone names.count instead of bones.length. And then right here, instead of saying bones.name.get hashcode, we can just pass in bone names i.get hashcode. And that gets rid of the .name call, gets rid of the renderer.bones call, and it gets rid of the bones.count call, but I mean, that doesn't matter. So let's save and make sure everything is still working, and then we can compare the profiler to see if it's actually worth doing that or not. First, let's go into our items and make sure that it updated our bone name. So this has shoes, and we open it up, and it's got a bunch of bone names. Cool, so it worked. Let's click play and see if we can equip the item still, or if it's just completely broken. Pick up our boots, and they equip just fine. Helmet, chest. Excellent, everything's working. So let's open up our profiler and make a profiler comparison to see if that was worth doing, or if we should have just left it how it was. Pick up an item, we'll do it with our chest. Click record, or we need the deep profile. Click deep profile and record. Let's pick up an item. I think this one is the one that has an item on it. Wait for this to stabilize a bit. Once it stabilizes, drop it on and click pause. So drop, pause. Well, we got 2 spikes. Uh-oh. Shiitake mushrooms. That's never happened before. Do they both have an add item call? Or add limb, I mean? This one does not have an add limb call, so that must just maybe a deep profiler editor thing. Here's our add limb call. But you can see it's only 240 bytes of garbage collection and took 1.15 milliseconds. So that is definitely worth it. Definitely. You see this spike right here? This was a garbage collection spike. Don't know why we got it, but how much kilobytes we were applying for each item that we were equipping before would have caused a lot more of those garbage collection spikes. And your game may have been running perfectly fine. None of your code's actually lagging, but you're getting these weird spikes. Garbage collection. So if your time millisecond is perfectly fine and your garbage collection is like 5 kilobytes or 1 megabyte or 10 megabytes, you need to stop and take a deep look at your project and see what's wrong. So you can see we made a huge improvement by doing that. It's totally worth it. Might make our file size a little bigger. When you build the game out, it needs to build out all those bone names into the item objects. But the slight file size difference is definitely worth the game running better while people are playing it. Everything works just as expected. The last thing we need to do is just add in the ability to do shields and swords, and we'll be done. Shields and swords is pretty easy too, luckily. We just need to instantiate it and apply it to a transform. I'm sure most people, if you've gotten this far in this video, you could probably figure this out on your own, but I feel like I would be cheating people if I didn't just go ahead and add it in. So let's go ahead and add it in. So shields and swords are going to be done completely different. First, we need to make the transform of where it'll be applied at. So we'll say a public transform. And for the sword, we need a transform for when you're holding a weapon in your main hand. So we'll call it weapon transform. Now we need a transform for when you're using a shield. We'll call it offhand wrist transform, because a shield usually goes on your wrist. But in our game, you're going to be able to use a weapon in your offhand too. So we need a transform for where the weapon goes. We'll say offhand hand transform. I wonder why this one's not grayed out and these are. It's strange. Okay, anyways. Let's go down to here. And we'll do the weapon first because it's easier. All we have to say is instantiate item underscore slot dot item object dot character display. And we want to put it on the weapon transform. And let's return the transform. Now we're going to do the same thing for the shield, except when it is a shield slot that we're applying it to, we need to do another switch case. And this is going to go over the underscore slot dot item object dot allowed items, or dot type. Now let's put our cases in, and we just need shield and weapon. Guess it would have been easier to type it than doing this, I suppose. So if your item type is a weapon, we're going to instantiate the character display and apply it to your offhand hand transform. If it's a shield, we'll apply it to the offhand shield transform, or wrist transform, I mean. Excellent. So that should work. The only thing that may not work is the positioning of our items, possibly. Let's go back into Unity. We also need to actually import the models for those things, don't we? We don't have a sword. Okay, I'm just going to import the models real quick. I think that you can probably figure out how to import a sword and shield model on your own, so I'm just going to drag it from my other project to make it easier. This video is already long as absolute crap, so yeah. So we have a shield and we have a sword. We just need to apply these to the correct items they belong to. Let's just find a sword. Sword 1, models, it's a sword. Now back into our items, find our shield, models, shield. Let's click play and pray this works and we don't have to do anything else. Didn't work at all. Got a null reference exception. We accidentally still had our offhand equals bone combiner at the end of our switch, so let's remove that, click play, and see if this works. That's not looking promising for if the shield's gonna work. Okay, that sucks. Oh, we never applied the transforms to our player. So we applied the sword to our sword 1 and the shield to our shield. Now we need to create the transforms for where they're going to get put at when they are instantiated onto our character. So let's open up our character's armature and find his arm. Let's see, your left arm is your shield, and we'll use we'll use left forearm. So right click, create empty, and this is zeroed out right here. Let's add in the prefab or the model for the shield that we added to the game onto here. And now the shield is zeroed out completely. We want to make our game object, make it to where whenever the shield is added at 000 onto here, it's just going to look correct. So we want to rotate the game object and not the shield. So let's do that. Rotate it like this and like this. Is that correct? Let me think. Yeah, he should be holding it correctly like that. Now let's just move it a bit. Once you have it in a spot that you think looks good enough, we can delete the shield. Go to our player, add this transform as the offhand wrist transform. Let's click on play and see if that worked. Excellent, it worked, but our shield's backwards. So we'll just re-add the shield to here. Make sure your shield is zeroed out. Click on the game object that is holding the shield. Rotate, and just give it a quick 360. Re-delete the shield. Click on play. Equip your shield, and there you go. You have a shield, and you have body armor. So you have non-boned item equipping and boned item equipping. I think you can technically add your helmet as a non-boned item also. Oh, we still need to add deleting in, don't we? But yeah, it's your choice. For the helmet, that is, not the deleting. Well, I guess deleting's your choice too. Let's quickly make the transforms for our sword and the other hand transform. So this is wrist transform. Let's just duplicate it. Drag our sword onto here. Call it hand transform. Make sure the sword's zeroed out and get this looking correctly. Should be good enough. I'm just trying to do this quickly. I've already spent quite a bit of time in this video. Let's see. I'm going to open up OBS and let's see how long it's been. It's been 2 hours and 30 minutes. So yeah, I'm trying to get this finished. Let's open up the other right forearm. Create an empty. Move it to the hand spot, put a sword on it, rename it to hand transform. Zero your sword out, she's zeroed out, rotate this correctly. Good enough. Delete your 2 swords, go to your player, drag your transforms in. Make sure weapon equipping is working. Alright, we'll pick one of these up, equip your shield, equip your weapon, save, load. See, it auto added those items. Let's go pick up another sword. Oh yeah, we don't have deleting added in, so this isn't going to work. But you'll see it so it added that item there. So we just need to delete the items now. Deleting items is easiest part out of everything. We just need this exact same switch, including the if. We can get rid of this default actually. First, get rid of your default. Now copy the if. And we're in on add item, so let's go to on remove item. Paste this in. Instead of setting the helmet, let's just destroy the helmet. So destroy the sword, destroy the offhand, and we don't need to do a check on this one because it's always just the offhand variable being set. So we can get rid of the extra switch inside of here. Destroy the boots, and destroy the chest. And I did memory test on this, and there's no memory leaks from doing it. You're not adding more bones to the game. You're only affecting the object that gets added and not the bone structure of your player. So just destroying the object works perfectly fine. So let's see if we can destroy items now. Let's just load and try to take something off. Excellent. Cool. So let's pick up another sword and see what dual wielding looks like. Let's focus on our player with Shift F. And, oh, we equipped the wrong weapon. Equip the one that has a sword on it, and there you go. We have a dual wielding player that can also equip items. I hope with this video you figured out how this works and how you can make it more performant, and maybe some more ideas of how you could make it even more performant. One thing I'd like to point out to you is if you go to your armor set body nude, go to your rig, you have this optimize game object button which will hide all of these transforms, and then you can select which ones to expose. So if you're not using every finger in your hand to bend your hand, you can hide those armatures and just use the fingers that your item object requires to bend your hand, and it should work fine. Or if you're not using any legs at all and you're just using chest piece on your character, you can only expose the bones that the chest piece needs, and it'll help with your game performance a ton. So that's just one thing to keep in mind. That's there to use. So if you wanted to add the tag to here to check for the tag, you would literally just say if child.compare tag and then type in the tag. So like maybe you have a tag called armature, and then you can just apply that armature tag to the actual armature in your root character object. But I'm not going to do that, but that is how you could do that. So I'll show you what I was meaning by the file size difference. This is the armor set of our nude character. This is the full armor set. So for every single piece of armor on the armor set plus the armature, it's 1600 kilobytes. For your armor set gloves deleted bones, so this is a pair of gloves with only the glove bones, it's 563 kilobytes. It's 1/3 the size of the entire set, and in the set there's helmet, chest, pants, boots, and glove. There's 5 pieces, so you can see you'd be increasing your overall file size a lot if you separated all these out. So maybe think about a way where you don't actually have to separate the items, but you could somehow only store the bone names. So changing this code to only store the bone names that that item requires instead of storing every bone on it. That way, when it stores these bone... Oh, I'm not even looking at the right spot. That way, when it stores these bone names inside of onValidate, it'll only store the bone names that it needs to store, which will in turn make the bone combiner only need to look up the bone names that got stored. So if the code is understandable to you so far, maybe that makes sense to you why that would help on performance a lot. It would cut your calls down from 67 to like 5 while also keeping the file size of having everything with one armature. So that's just something to keep in mind. Little extra information I'd figure I'd throw on the end. Yeah. I also just suggest getting JetBrains to fix all your stupid naming problems like that. And it also tells you cool things like this. This list string bone names can be an iRead-only list. That's kind of cool. And then apparently this transform can be an IEnumerable, which that's kind of cool too, right? All right, I believe that's everything that I need to show you in this video. In the next video, we'll be doing some refactoring to just clean this project up. So yeah, I hope you enjoyed it. If you did, leave a comment below. Consider subscribing to the channel. And until next time, have a wonderful day and stay coding.